Hello, in this video tutorial I'm going to show you how to build a graphical user interface in MATLAB. The presentation will start with a brief introduction on what is going to be presented here and a few general notes, then followed by the detailed description of each of the two approaches that can be taken in building a graphical user interface. At the end, a brief summary will be made on what was presented here. There are essentially two ways to build and control MATLAB-based GUIs. In either way, there will be one file with FIG extension, which contains only the layout of the GUI and the properties of each GUI component. In the first approach, there will be two files in use. One file that we provisionally here call name.fig file is just your GUI. Another file called name.m will contain the functionality of the GUI and all the functionality of the user code. By the second approach, there will be three files in use. One file will be name.fig that contains merely the GUI itself, as usual. Another file with the same name but the M extension will contain only the functionality of the GUI itself, while in the third file, which is that one extra file that we here provisionally called name2.m, all the user code functionality will be contained in it, while the file will merely read from or write to the name.m file. This is just a general concept of what is going to be presented, and each of the above two approaches is described in more detail next. So let's begin with the approach 1 that uses two files. The procedure to do this is the following. First, one needs to open guide environment in MATLAB. That can be done either by clicking on the icon in the MATLAB toolbar or by typing in guide in the command prompt. For example, let's click on the icon. Then we are offered to either create a new GUI or open some of the existing GUIs. For an example, I will choose a blank GUI to open here, just to show the initial environment and the canvas. So we have the canvas to lay out our GUI components that we can choose from the toolbar on the left. Here, when you browse, one can find the component for plotting some values, for the radio buttons, for input of the text, for static text, pop-up menu, list box, etc., etc. One of them is the slider, and so on. So the components are simply selected from the toolbar and dragged here on the canvas. Similarly, one can do this, move the another component, and so on. After we put the desired components on the canvas, one needs to set up the properties of each component. So let's go back to the presentation and show the rest of it. So the second thing after putting the components on our canvas, we need to adjust the properties of each component. We will show how to do that. At the end, one has to save the design under some name. In this example, we will say, let's call it first, as a first example. The file will automatically get extension .fig, and following that, MATLAB automatically creates and opens another file named first.m. That file will contain two functions for each GUI component. One function is create function and another one is callback. So under specific callback functions, one then needs to write the user-defined code. Let's see the above procedure on one simple example. So after opening the guide, as I just showed, we design a GUI using various components. We see this toolbar on the left, and for the sake of this example, I just created calculation of two functions here. In one case, I have a slider that enables me to set the base, and in another slider, the exponent that together will give me some result based on the function base to the power of the exponent. On the right side of the canvas, I placed a plotting window and the simple function y as x to the power of exponent, where x goes from 0 to 10. So after placing the components of on the screen, on the canvas of the guide environment, we can do a left double click on a component or a right click and choosing the property inspector item on the menu to open the component, the property inspector. Within the property inspector, various properties of the component can be adjusted to the user preference. However, the two most frequent ones will be, for example, minimum and maximum value of the component, if that is a numeric component, such as slider is, and definitely the tag, which is the ID of the component by which we can access the value of any particular component. After saving the GUI design, MATLAB will automatically create an M file with the same name as the GUI. In our example, the name was first. So first.m is automatically generated, which is shown here on the screen. So we can see that for any component on the GUI, like the base or the exponent, the M file has two standard functions. One is callback function and another one is create function. So within those functions, user needs to add specific functionality of the code. In fact, create function can be left intact, at least in the basic usage of this, and the user-defined coding has to be placed under callback function of the particular component. You can see here on the picture that the base retrieves the value of that component, while the exponent retrieves the value of the slider called the exponent, and so on. The result is produced by base to the power of exponent with necessary adjustment of the types, data types. So we here convert from numeric type to string type, which is necessary to correctly present the result. So these are the details that one has to pay attention, otherwise we can get some implausible values within the components. So that note is put here in these comments to be aware of the default data type of every GUI component with respect to the data type of your variable and to match their types by adequate data type conversions. Okay, so if the application ultimately is not working properly, the two most likely causes of error are we either miss to match data types or there is an incorrect tag of the GUI components that we are using. After Doing this, we ultimately end up with two files in use by this first approach. On the left, there is our GUI design under first.fig name, and on the right we see part of the code within the first.m. That pretty much concludes the first approach, and we can discuss now some advantages and drawbacks of the first approach. As advantages of the first approach, we can say it has only two files in use that have the same name, whatever the name was assigned. For example, name.fig and name.m, or first.fig and first.m, whatever. Also, the user-defined coding is contained within the M file, as it is shown here. On the contrary, user-defined coding loses some readability due to a large number of the callback and create functions that relate to GUI design. As we said, for any GUI component that we have, the two functions called callback and create function will automatically be inserted in this code, with a number of comments that are also automatically generated, and that can simply burden readability of user-defined coding like here. Another drawback that can be observed here, that in order to read the actual value of any component, we will have to repeat some portions of the code under multiple callback functions of various components. Like here we see pretty much the same code under the base slider and under the exponent slider. Now let's talk about the approach 2 that uses 3 files. Talking about the procedure, we can say that there are only a few steps that are different than in approach 1. So we can say that first 3 steps are the same as in approach 1. The difference is that we need to create an additional M file of some arbitrary name, for example name2, that has an input argument called handles. And within this file we write our user-defined code almost as if no GUI will be used. After that, we adjust the syntax only in those lines that contain variables that communicate with GUI file name.fig. Finally, to complete the communication between the GUI file and the user-defined file, we use the other M file in a way to put a function call of the form name2 with the argument handles within any function of the name.m that contains some GUI controlling component. So the best way to explain this is by another example, and so let's show and discuss another example that we now call second, which will contain 3 files: second.fig with merely a GUI file, second.m that contains GUI controlling functions, and second2.m, which is another M file that contains user-defined coding and call almost as if no GUI was there, was planned for that. Okay, so let's see it. The step in the beginning is equal as in approach 1, as we said, so we need to design the GUI, and we show that here, so there is no difference here. Also, we need to adjust the GUI properties. There is also no difference in this part of the procedure. And finally, we save GUI as under new name second.fig in this case, which automatically generates second.m file. Now let's show the difference. In this moment we need to create a new function having a new name that has handles as an input argument. So as it's emphasized here, we created a new function that we call second2, which has one argument called handles. This function can initially be written as if its code will not communicate with the GUI, so that's nice to know. So we pretty much write a simple MATLAB code as it's shown here, and using handles parameter we adjust those lines that have to communicate with the GUI components. So if we have to read the value of the GUI component, we use the get syntax, get function. If we want to set the value of the GUI component, the set function will be used here. And finally, we need to adjust the automatically generated M file. So, however, the adjustment here is very simple. We open the file and we insert a function call of the form second2 with the argument handles within any function in second.m that contains some GUI controlling components as it's shown here. So to enable communication of our pure user code with the GUI, we simply paste one same line under any callback function of the components that are used in our code. Ultimately, there are three files under this approach. The GUI file that we designed, then automatically generated second file, second.m, that has these calls of second2.m file with the argument handle. So we see these function calls here, and this file, when we deleted some comments, is very short and simple, and we can see it looks as a typical M file, as if no GUI will ever be used. And only those lines in that file that have something with the GUI components, they are adjusted. However, the rest of the code can stay intact. Similarly to first approach, let's talk about pros and cons of this approach. The good sides of it are the code is more readable, since all the user-defined code is within a pretty typical M file and free of numerous GUI-related functions, and simply communicates with the GUI via get, set, or plot functions. Another good part of it is that GUI-related M file has one same function call only at the places where some GUI control components change their value. So this approach is convenient when the user wants to add GUI to the code that originally did not have a GUI. And I especially like that part, which enables us to add some GUI functionality even to our older codes that were originally not written with GUI in mind. What can be the drawback of this? Well, possible drawback that one can see here is that instead of having two files, one has three files, because we need one more M file to do this communication between the GUI and the user-defined coding. So in the summary, I presented two ways of building GUI for MATLAB codes. In my opinion, although it requires one extra M file, approach 2 is more convenient for the two reasons: the better readability of the user-defined code and easier addition of GUI to the MATLAB files that were originally not written with a GUI or with GUI in mind. So at the end, I hope this tutorial helped you in learning and understanding how to simply and effectively build your own GUI, and that after watching this you are ready to do some coding and build your own GUI with MATLAB files. Hopefully you enjoyed it, and I wish you best of luck. Thank you.